Welcome. Thanks, Isaac, for putting on the Innovation Showcase. My name is Alex Hyler, and I'm the Vice President and Chief Scientific Officer. I'm excited to tell you about our label-free cell sorting platform we're developing at CytoRecovery. Let me tell you why we're here. Our customers have told us that flow cytometry is incredibly good at what it does, but it has limitations to meet today's cell sorting needs. You can often take really long times, lose a lot of your cells, and often miss rare cell subpopulations. Most importantly, the cells cannot always be used downstream for further assays. We strongly believe that if we're going to move towards personalized medicine, it requires precision cell recovery. Enter the CYTO R1 platform. We've developed a fully integrated, software-controlled benchtop solution in order to provide faster sorts with high viability recovery and allowing rare cell subpopulations to be captured. We do this on our lock and load interfacing system, and the core of the magic happens in our sterile single-use CYTO chips. Let's walk through the CYTO R1 workflow together. Everything you need comes packaged in a sterile and disposable kit. This includes our CYTO chip, syringes for loading your sample, tubing and lures to connect them, as well as a priming step. You'll load your blank reagent into a syringe, as well as your cell sample into another syringe. From here, you connect a tubing and lure, and then it's plug and play as we connect to the chip. Here, we load our blank reagent into one of the inlets. After that, you can hook up your sample into the other inlet. After that, you connect a plug and play lid that introduces the electronic environment into the system. Once everything's connected, you can then use our software control to tune your electronic environment and flow rates and begin your sort, all while visualizing on your microscope of choice. So let's dive into a CyTO chip and tell you how the sorting actually works in a completely label-free environment. Inside each sterile and disposable chip, there are over 20,000 micropillars, acting kind of like a Plinko device to attract or repel cells, depending on how we tune the electronic environment. Here, we tune to attract the yellow cells, and we allow all the other cells to enrich and pass through. The yellow cells might be our targets, or maybe they're in our way. Whichever way you want to do the workflow, the yellow cells can then be reversibly released and collected in a separate bin. All of this is done label-free, exploiting phenotypic features of cells like their membrane morphology, their nuclear charge, and other factors. So how do we get to these bioelectrical signatures, and how different are they? Here are some representative examples based on frequency and voltage for oncology-related cells, and you can see their unique bioelectrical signatures. So how does that actually work in practice? One thing we can do is do viability enrichment for single-cell genomics and make sure to preserve heterogeneity. We can enrich all the way above 90%, keep the heterogeneity of the original sample within 5%, and then recover at least 60% of your sample, something critical when you're looking at single cells. Another example, neurons, notoriously picky. We can enrich them from satellite glial cells or other isolates. We can preserve their viability, and we can also begin sorting smaller and larger neurons for further enrichment and other applications. Lastly, let's talk about macrophages and fibroblasts, and let's see it in action. Here we do label the cells, which is not a problem. You can label them upstream or downstream. It's just not required since our platform sorts based on phenotype. Here, the fibroblasts stop that are green, and the macrophages continue through. You'll see it again. Here they stop on the pillars while the macrophages continue through. Now that we've talked science, let's talk about the business. We have a strong IP position. All of our technology is exclusively licensed from Virginia Tech and UVA, and we've also created a partnership with UC Irvine to expand our applications capabilities. The company itself has also filed over 4 applications with more pending. We have a strong track for fundraising, with $4 million raised to date in venture funds and almost $2 million in non-dilutive grant funding, including an active NSF SBIR Phase 2. Our leadership team is strong and in place. Steve Turner has taken multiple companies public, and our inventors are still involved advising the company to this day. The core of our team is based in Blacksburg, Virginia. Where have we been and where are we headed? Our first orders were received as we launched our Gen 1 product last year, and we're continuing to raise funds. Looking ahead, we're excited to expand our sales funnel and continue our operations on other continents. Even further ahead, we're excited about our knowledge database and potentially Asian market expansion. But right now, we're truly focused on customer development, our field application specialists, making sure we can scale our manufacturing, and continuing to deploy new features that our customers desire. We're excited to sort your cells as they are. Thanks for your time and have a great day.